Lagrange interpolation techniques. Introduction. Lagrange interpolation is a method for estimating the value of a function using polynomials that pass through given discrete data points. Unlike Newton's interpolations, Lagrange's formula does not require differences and can be used for both equally and unequally spaced data points. Now you can see here Lagrange interpolations formula for a given set of n plus 1 data points x naught comma y naught, x1 comma y1, x2 comma y2, and so on. The Lagrange interpolations polynomial is given by px equal to summation I equal to 0 to n yi li x, where Lix is the Lagrange basis polynomial. This is a general formula. Each term Lix ensures that the polynomial passes through the given points. Now we will start example. Using Lagrange interpolations, estimate f of 2.5 from the given data. The value of x is given. The value of f of x is given. Using Lagrange formula, since we have three data points, the Lagrange interpolation polynomial will be of degree 2, means quadratic. Px equal to y naught L naught x. You know this is a formula of Lagrange formula because we are given three values. Then y naught, y1 and y2 will be use this formula. Where this is a formula is L naught x equal to x minus का x1 x minus का x2 divide by x minus का x1 x naught minus का x2. Same process we find L1x. Now you can see here L1x equal to x minus का x naught x minus का x1 x1 minus का x naught x1 minus का x2. Same process we find L2x. The formula is given. Step 1. Compute the Lagrange basis polynomials. For x naught equal to 1, x1 equal to 2, x2 equal to 3. Now you can see here L naught x equal to 1 minus का 2. It means minus का 1. 1 minus का 3. It means minus का 2. Minus का 1 minus का 2 multiply plus get 2. You know the formula is also given, and putting these values we get 2 minus का 1 means 1, and 2 minus का 3 means minus का 1. Then plus का 1 multiply by minus का 1, we get minus का 1. Same process L2x. 3 minus का 1, it means minus plus 2, and 3 minus का 2. Now you can see here 2 multiplied by 1 in we get 2. Now compute the interpolating polynomial. You know this formula x equal to the value of y naught to L naught x plus the value of y naught 3 or y1 3 L1 x plus the value of y2 L2 x. Now substituting L0, L1, L2, which we have find in a previous slide. Now you can see here 2 is here, L0 we write same, plus sign is here, 3 is same, L1 the value is L1, plus sign is we write plus sign, L2 value we write L2 value, and 5 is given. Now you can see here 2 will be cancelled. No any numerator and denominator plus sign. How can we convert minus? You can see here minus ka 1 multiplied by this number minus ka 3. Then 5 upon 2. You can see here 5 upon 2 same process we write here. Now we simplify these values. You can see here we simplified these values. You now first you write x multiply by these numbers, then minus ka 2 multiply by these number, then we simplify, get value these x square minus ka 5x plus ka 6. Same process, first you write x multiply by x minus ka 3, then minus ka 1 multiply by this number, then we simplify, we get this answer. Same process you find here, substituting back x equal to, you can see here, we write here, then you put values, second values is also given, then you put these values, and third value is also given, then we put these values. Now we open all brackets. After the open all brackets, you can see here the value of x square we write here, the value of x square minus ka 3x square, the value of x square 5 upon 2 x square. Now we arrange value of x minus ka 5x we write here, then plus ka 12x we write here, and 15 upon 2x we write here. Here is given minus sign, then you write minus sign. Plus we write all numbers, 6 you write here, minus ka 9 you write here, 5 you write here. Then we simplify. You can see here minus ka 3x square x square. We get minus ka 2x square. Then you write same values. Then you can see here plus sign, plus ka 12 minus 5. we get plus 7 minus 15 upon 2x. You write here. Then simplify these numbers. Then we get plus 2. Now you can see here how can we simplify. You can cross multiplication. You can get LCM. If we get LCM, then you can see here. We write here 2 to the 4 x square plus 5 upon 2 x square. Plus sign we write same. You can see here we can multiply cross multiplications or LCM method. 2 7 14, 2 1 2 minus sign 15 upon 2x. Then you write same 2. Now you can see here plus 5 minus 4. We get 1 upon 2x square. 14 minus 15 minus 1 upon 2x we get. Plus 2 you write same. This we get the simplifications of the questions. Now thus the Lagrange interpolating polynomial is, we get the answer. Now compute P2.5. These values are given in questions. P2.5, it means all values of x, we put in the values of x 2.5 and 2.5. Then we simplify 2.5 multiplied by 2.5 because here is given square. It means 2.5 multiplied by 2 times minus 1 upon 2, 2.5 plus 2. Now we divide by 2 we get, and divide by 2 we get this number. Then we simplify. The final answer 3.875. Thus f of 2.5 approximate 3.88 using Lagrange interpolation.